Okay, so hello everybody. So today what we're going to be talking about are problems related to naming aromatic compounds and some problems relating to synthesis utilizing aromatic compounds. So this actually was at a request from somebody. She asked to answer questions and reactions related to aromatic compounds. So before we start that though, what I want to do is actually go on my Twitter page, and I'm going to show you. I actually put the video up, the last video, the second video, on my Twitter page, and I commented here saying the software that I use, and actually Microsoft OneNote replied to my comment, and we got into a lengthy discussion. So if you're actually interested in that discussion or you want to follow it, make sure to follow my Twitter handle, which is in the description box below. So we're ready to begin. So let's start naming this first compound here, right? So we're going to name all four of these compounds, so we're going to start with this one, right? So this compound here, let me just grab my pen. Okay. This compound here is probably one of the compounds that you should actually remember, like just memorize. So we have a benzene and we have this acyl halide group, right? So we would refer to this as benzoyl chloride, right? It's one of those compounds like toluene, aniline that I would just remember by memorization. If instead of this Cl we had an OH, we would call this benzoic acid, which is another compound that I think you should just remember off the top of your head. So anyways, let's go to the next one here. This one's a little bit harder. So we have this ester group. So we know with esters, our suffix will be, it will be O8. O8, right? So now we want to count the number of carbons that's attached to this carbonyl, right? So 1, 2, 3, 4, 5, and you've got to remember the carbonyl carbon 6. So we have a 6 carbon chain. We have an ester. And we have this. So this is actually where it gets kind of tricky. I remember I had some trouble with this when I was taking the course. So this group, the benzene attached to the CH2, that's actually referred to as benzyl. Okay? Now if we had this instead, this compound instead, one, 2, 3, 4, 5, 6. If we had this compound instead, because the benzene's not attached to a CH2, it's actually referred to as a phenyl. That's a baddie. Phenyl group. Okay, so back to this compound. So we have a benzyl. We have a 6 carbon chain attached to the carbonyl. So this will be referred to as benzyl hexanoate. Sorry. Hexanoate. Okay, so now let's go to this compound. We'll apply the same technique to this. So this compound, we have an amide group, so our suffix will be amide, right? Now the carbonyl is actually attached to 4 carbon. So we have the carbonyl carbon, we have 2 here, 3 here, and 4 here, right? So we have a 4 carbon chain. So 4 carbon chain, right? And now we actually don't have the benzyl, right? Because this benzene is attached to a CH, not a CH2. So that's actually a phenyl. So we're going to refer to it as a phenyl. And the last thing to point out is that the amide on the nitrogen side is attached to a methyl. So when you have that, you're going to put one N and then dash methyl. Right? Now if it was 2 CH3s attached to the nitrogen, then it would be N dash N, N comma N dash dimethyl. Okay, so now we're ready to put the name together. So this is actually N-methyl. I'm gonna actually erase this real quick. Okay. N-methyl 2-phenyl, because the phenyl is attached to the second carbon on the butyl chain, which is the longest chain in the compound. Let me just get rid of this so I can have space to write. N-methyl 2-phenyl butanamide. So that's the name of that compound. Okay, that one was a little bit more trickier. So for this one here, the last one, we have the carboxylic acid. So our suffix will be oic acid. That's our suffix, and because it's the highest priority group, and I'd suggest that you look up the priorities of the different functional groups in terms of naming and keep that list in hand, because that would be useful. Okay, so we have that carboxylic acid, which is attached to how many carbons? We have the carbonyl carbon, which is 1, 2, 3, 4, 5, 6. So we have a 6 carbon chain. Now we have a methyl in the second position because we're counting from the carboxylic acid, which is the highest priority, right? So we have methyl. What I like to do is I'd like to just put in brackets 2, denoting second position. And last but not least, we have the benzene, right? The benzene is attached to a CH, so it's actually not a benzyl, it's a phenyl. So now we're ready to name, right? So we're going to start with, let's start with the end, right? So the carboxylic acid is attached to a 6 carbon chain, so it's going to be a hexanoic acid, right? And we have the phenyl. So remember, we go by alphabetical order, right? So the phenyl is going to come right before the hexanoic acid, and the phenyl is in position 5, right? It's on carbon 5 in this carbon chain. So 5-phenyl, and then we got to remember this methyl, right? It's going to be 2-methyl, 2-methyl, 5-phenyl hexanoic acid. So that's how you name that. Okay, now on to the fun stuff. So next question is this. And this was actually, so I used to do this program called discussion sessions. I was a discussion session leader for this Organic Chemistry 2 course that I used to volunteer for. And this was actually one of the challenge questions that I created for those discussion sessions. So it's really basic, right? Prepare the following compound from benzene. And what's implied in this question is that you could use anything else in addition to benzene to prepare the compound, as long as you have to start with benzene, right? So we know benzene kind of looks like this, right? So we have to get to this step here. Now, usually what you want to do is a retrosynthetic analysis, right? So the way I see it is to get the this kind of, and this is, I think, naphthalene. I'm not sure about the name of this compound, but to get this kind of second aromatic ring attached, I would presume that I would somehow have to get to, I'm actually going to leave a space here. I would have to somehow get to this point here, right? Because I could see how from this point I could get to here, right? And the way we do that is, and different universities teach these in different orders, but the way we get from, here to here is actually I'm gonna draw this the way it's drawn, just so that nobody gets confused. But don't worry, you could draw it the mirror way and it would be fine, right? So the way we get, from here from this compound to this compound is actually through this compound. BR, and gotta scroll down a little bit. And you can do that through an elimination reaction, which the elimination reaction I think is usually taught in the first part of organic chemistry. Now, the way to get from this compound here to the BRs is by using either BR2 and light, or what's the other reaction? And sorry, let me just say, or NBS and hydrogen peroxide. So from here we could get the BRs onto the carbons that are directly attached to the benzene, and from there we could do an elimination reaction to get to our final compound. Now the thing is, we have to figure out how to get from here to here, and that's actually pretty easy. So you would use here Friedel-Crafts. I'm just going to say Friedel-Crafts for now because we have to decide between alkylation and acylation. And that's the usual way of adding a carbon chain onto a benzene, right? Now we have to be a little bit creative. So let's go down here. So first off, how many carbons are we adding? So we are adding a total of 1, 2, 3, 4 carbons, right? So we know that if we start from benzene, we are going to need some type of compound that has four carbons, right? Now the thing is, you can see that you can see how here we're coming from a straight chain, right? Because there's no branches on this ring, right? So if we want to put a straight chain onto the benzene, we actually have to do Friedel-Crafts acylation, right? So we have to add the acyl halide, not the halide, because if we add the halide, then it'll rearrange, and then you won't be able to get that straight chain, right? So we're going to do that. We're going to add that 4-carbon chain with the acyl halides, and our catalyst is aluminum trichloride. And what this will do is, you can imagine the first, and because it's symmetrical, it doesn't matter which acyl halide attaches first, but you're going to get something like this, right? And if there's more aluminum chloride in solution, this chloride here attached to the carbonyl will actually get attached to the ring on the other side. So you're going to get something like this, right? Now, this is looking a lot more closer to this compound here. We have to get rid of the carbonyls, and I'll go through that in a bit. But once we get through the carbonyls, we're almost there. Now, how do we get rid of the carbonyls? So there's two ways to get rid of the carbonyls, right? You could do this reduction here, zinc with mercury and HCl and heat, or you could do a Wolff-Kishner reaction, right, with hydrazine, NaOH, and heat. And that will get rid of your carbonyls. And then what you want to do is Br2 and light, or NBS and hydrogen peroxide. And you want to do this in excess, right? So in excess. That's bad handwriting. In excess, right? And what that will do is add bromine on both secondary carbons, because these secondary carbons are really stable because they're attached directly to the benzene. So the bromine can add to both of them, right? And then from there, you want to do an elimination. Now, for the elimination, is actually, if you remember from your first part of organic chemistry, you could do tert butoxide in tert butanol, so that'll be our solvent. And I believe it will go through an E1 elimination reaction because it forms very stable carbocations. Once you remove the bromine, you could imagine the carbocations that are formed on this carbon and this carbon are very stable because they can resonate with the benzene, right? And the hydrogens on these adjacent carbons will be eliminated through that E1 mechanism, right? So you end up with something like this. I didn't want to go through the mechanism of the reactions. That would take way too much time. But that's the gist of how to do that synthesis. Now, I know it was a little bit disorganized, and I realized this as I was explaining it. I didn't go through all the intermediates in my retrosynthetic analysis, and I don't recommend you guys to do that if you go through a similar question in an exam or anything. But this was really hard to start from behind, right? This wasn't actually a retrosynthetic analysis. I actually went forward, but like, you have to imagine, okay, if I'm starting from here, then I have to somehow get that ring attached, so I have to go through this. Now, to go from here to here, there are intermediate steps. But and how do I get to this? Well, I have to do a Friedel-Crafts reaction, right? Because that's the usual way of adding an alkyl chain to benzenes. So anyways, that's how I would go through that question there. It was a tough question, but it's a good exercise because it goes through a lot of different reactions that you guys learned in the aromatic chapter of your course, right? So that's the end of it. So before I end the video, I have a couple of things to announce. I might start this program where I'm gonna be distributing some summary aid sheets. So I've done this program called Facilitated Study Groups where I've kind of tutored students in Organic Chemistry 2. That's something that's offered at my university, at the University of Toronto. When I was doing that program, I kind of created these summary sheets. So this is one of them, but I think I have like 5 or 6 for just Organic Chemistry 2. And I have a version that's answered and not answered. So what I'm thinking of is distributing it to people who subscribe. So I haven't decided on it yet. I want to just speak to some people, some professors at my university, just to make sure I'm not stepping on anybody's toes. But if I do, I will distribute this to maybe the first 50 subscribers, and then we could think about some other promotions in terms of that. But that's the only announcement I have. So if you have any questions about this particular video, please make sure to leave it in the comment section. If you have any questions that you want me to answer in the future follow-up video, send it to qusai, so here's the email, QUSAI chemistry tutor at gmail.com. I actually really don't know why I wrote it because it's in the description box below, but there it is. Make sure, if you like this video, make sure to hit the thumbs up, subscribe, and click the bell notification icon if you want to get notifications whenever I upload a video. And if you like this video, also make sure to share it with your friends. So I'll see you guys later.